Okay, so yes, if I pick the spring up, what type of energy does it have, Darian?
GP,
Very good.
gravitational potential.
Gravitational potential energy. Okay, it has energy due to its position and gravity. When I let that go, what kind of energy is that going to turn into? When I let it go, what kind of energy is that going to turn into?
Mechanical.
Very good. Mechanical energy. Okay, yes, that turns into kinetic energy in the form of mechanical. So when I let go, we have mechanical kinetic energy. When it's out here at the very bottom, I have to actually drag it to show that. But yeah, you can see the green. Let me let go. The green bar there is kinetic energy, and you'll notice, where does that have the most kinetic energy? In the very middle. So if I let go, see, in the very middle. So here's what happens when a spring. As it starts to fall, it gets faster, but when it starts to stretch out, is it speeding up or slowing down now? It starts to slow down, right? Because that kinetic energy, and you can't really see it, but that kinetic energy, I wish there is a slow motion on here. So when I let go, that kinetic energy, watch the green bar. I should say that potential energy, watch the green bar, turns into what? It turns into kinetic energy. But then that kinetic energy starts to become potential energy in the form of elastic potential energy. So as I watch this spring goes back and forth, it actually has potential energy in two places. One at the very bottom in the form of elastic potential energy, and the other one at the very top in the form of gravitational energy. In the very middle, it has a little bit of each. Okay, it has kinetic energy along with some elastic and some gravitational. So this is actually a fairly complicated system, but with that being said, up here it has gravitational potential energy. Down here it has elastic potential energy. And in the middle, it has kinetic energy. Okay, so it's going back and forth between the two. It's going back and forth between gravitational potential energy and elastic energy. Okay? So with that being
said, I noticed with the spring, whenever you drag it down, total energy goes up.
Yeah, because at this point, it's because I'm dragging it. So that's a good point. Total energy shouldn't change, right? If I let go of it, watch what happens. Does total energy change? No, it just goes between heat, elastic. So there's a lot of things going on there. But if you notice, does the total energy change? No, because remember, law of conservation of energy. Energy cannot be created or destroyed. It just changes from one form to another. In this case, gravitational, potential, elastic, and heat. And the red one is heat. Okay, so one more time, we have gravitational potential energy, elastic potential energy, and in the middle, we have a little bit of everything, but that's where the most kinetic energy would be. Okay? All right, so next thing, one thing I need you to do, I guess first let's do the Kahoots. We're going to play, quizzes. We're going to play quizzes, and I accidentally closed it. Give me a second, and I will actually send you the link to the quizzes in the grade book. In the chat. Let's see. I made the mistake of closing it. There it is. Not that hard. Okay, so what we're going to do today is you're going to take two quizzes. One of the quizzes is over energy transformations, and the second quiz is your vocabulary quiz over the types of energy. So make sure that you're taking two quizzes today, okay? But first, we're going to play quizzes.